we're going to talk about speed and velocity. So if you want to find how fast something is moving, you're not concerned about the direction it's going, anything like that. You just want to know what distance is being covered per unit time. That's speed. And usually we just abbreviate it with an S, and it's distance divided by time. The units for speed can be anything. Meters per second, miles per hour, kilometers per minute. As long as it's a distance unit over a time unit, and that's all you need. It is scalar. When we talked about scalar already, we said scalar means it does not have anything to do with direction. So if you're asked for the speed of something, you're not being asked to tell the direction it's going, just how fast it's moving. Instantaneous speed is basically what you are traveling at any moment. So if you're driving down the road and you look at your speedometer and it says 50 miles per hour, and then 5 minutes later you look at it and it says 40 miles per hour, and then 10 minutes later it says 60 miles per hour. Each one of these is an instantaneous speed. The instantaneous speed for a trip, you wouldn't calculate it for an entire trip. You would calculate what's called the average speed. Your average speed is basically on the average how fast were you going through the trip. Instantaneous speed is how fast you're going at that moment. I mean, you could have been at a stop sign and it read 0 miles per hour. So that would be counting as an instantaneous speed as well. So the total distance covered divided by the total trip time. And when we're looking at that, it does not indicate any variations in instantaneous speed. So slowing down or speeding up is not shown if you're trying to figure out the average speed of something. So let's go back. Earlier we found the total speed for our, and solved for it by taking the total distance, which we already calculated was 420 the other day. And we would divide that by the total time, which is 3 minutes. So 420 divided by 3 is 140 meters per minute. So that would be your answer for total or average speed for the skier. Alright, so what if you were trying to find the average speed of the coach? Well, again, same formula. You take your total distance, which we discovered was 95 yards the other day. 95 yards divided by the total time. Looks like he's pacing for 10 total minutes. And when we do that, we get 9.5 yards per minute for our answer. Notice in either one of those answers that we didn't calculate or worry about direction. Here's our average speed formula. I already told you we usually do d over t. And here's some examples of different units of speed at ones you're used to. So you know what 50 miles per hour is, but you might not realize that you're driving 80 kilometers per hour at that point, or 22 meters per second. All three of those represent the same speed. same distance covered per unit time. They're just different units. So if you're driving 100 miles per hour, that's 160 kilometers per hour, or 44 meters per second. Now velocity is a whole different story, because velocity is a vector quantity. And with vector quantities, we need direction. So we have our little coordinate plane here. And I've already talked about this. Typically, things moving to the right, we call that positive displacement. Things moving to the left, we typically call that negative. Things moving north or up, we typically call it positive. And things moving south or down, we call that negative. Again, we can change this periodically, but for the most part, that's the traditional way of looking at it. Positives are up and to the right, negatives are left and down. So for velocity, we always have to include a direction. Okay? Speed by itself, no direction. Velocity needs a direction. So just to emphasize what I already was talking about, we have velocity being our vector quantity. We always have the magnitude. For example, if I'm driving 60 miles per hour, there's my magnitude. And then I would need a direction. Now, that little dash here looks like a negative sign, so let's just go ahead and make it negative. So if that's negative 60 miles per hour, that means I was either driving to the left or west or south at 60 miles per hour. You could also, of course, come in, say, 60 miles per hour north. That counts as a velocity as well. Or 60 miles per hour with a little plus sign. Take off the north. That's also considered a vector quantity. When you get down here with scalar quantities with speed, you just see 60 miles per hour. That's it. There's just a magnitude, no direction. So speed stands alone, velocity has direction with it. So the definition and the formula for average velocity: the total displacement divided by the time interval during which the displacement can occur. Now this displacement can be negative. We've already done some displacement problems where we got negative values. So sometimes the numerator, the top number, can be negative. So on your formula sheet, it might look something like this. Delta x is your displacement. And we already know that delta x equals your final position minus your initial position. Delta t stands for change in time. So your final time minus your initial time. Now your initial time, a lot of the times, is 0. But there could be times where you have a problem where ti might be something other than 0. But needless to say, we still need to mention that this number here is never negative. You cannot have negative time. The top number, though, can be. Okay? So time's always positive, and delta x is either negative or positive. But it always will end up helping you find the direction. Another thing about velocity you have to understand is it's a change in speed, but also direction. So if I slow down or speed up, my velocity is changing. But if I'm driving in this car at the same speed, even though my speed is staying the same, my velocity is constantly changing because my direction is constantly changing if I'm traveling in a circle. So it's very, very important when we get to acceleration. We'll talk about this as well. If you have velocity changing speed or changing direction. So if you're driving in a car and you come to a stop or you speed up, your velocity is changing. But if you're driving down the road and a curve comes up, you might stay around that curve the same speed, but because your direction is changing, while you're going around the curve, your direction's changing. And if your direction's changing, your velocity is changing. And that's how later on we'll identify what's called acceleration. So change in velocity can be two things, either speed change or direction change. All right. A race car driver has just completed the Daytona 500. He finished the race in 3.5 hours. Calculate the average velocity, calculate the car's average speed. So I want you guys to try it yourself. Pause the video, give it a shot, and then hit play and we'll solve it. All right, car's average velocity. Well, average velocity is delta x over delta t. And delta x is xf minus xi. And delta t is tf minus ti. Now if you look down here at the picture, we notice the starting line. Well, that's also the finish line. So if we just label that 0 miles, that is not only the initial position, 0 miles, but it's also the starting position, 0 miles. Or excuse me, that's not only the initial position, but also the finishing position. And then we're going to divide that by the time. Well, the time is 3.5 hours minus 0, so 3.5 hours. And of course, we're going to end up with a velocity of 0 miles per hour. So velocity for that race car, even though it went all those times around the track, doesn't make a difference because the starting point and the ending point were the same. Now speed is different. Speed, we're just doing what? We're trying to calculate the distance traveled by the time. Well, what's the total distance the car traveled? Looks like 500 miles. And how long did it take them to ride 500 miles? 3.5 hours. So 500 divided by 3.5 hours gives us 143, and that's miles per hour. Do I need to put a direction on it? No, because this is speed. With speed, we don't need direction. All right. Next one. How much time in minutes would it take a bobsled to cover a 5,000 meter course? So it looks like our delta x is 5,000 meters. It's very good practice to get into to write all your given values down when you're doing a problem. Traveled at 22 meters per second. And we're going to give this a direction since it does say velocity. I'm just going to say it's moving south. And the question wants us to find the time. And what's our formula for velocity? The formula for velocity is change in time, or change in displacement over change in time. Well, I'm solving for t, so I want to get t on the top. So I multiply t on both sides. And when I do that, I get vt equals delta x. And I want to isolate t, so I divide both sides by v. And the time I can calculate from dividing the displacement by whatever the velocity is. So what is the displacement? The displacement is 5,000 meters. The velocity is 22 meters per second. Trying to solve for time. So 5,000 divided by 22 meters per second is 227 seconds. Now we have a bit of a problem because the question says to solve for how many minutes. and not seconds. So what do we need to do with those seconds? We need to take them and convert them to minutes. So if I'm going to do that, I'm going to take my 227 and I'm going to multiply by my conversion factor, 60 seconds for every 1 minute. So 227 divided by 60 gives us about 3.8 minutes. For that problem. All right. What's the average velocity in miles per hour of Shaun White if he covers 1,200 meter half pipe? All right, so 1,200 meters. That looks like our delta x. In 1.2 minutes, t is 1.2 minutes. And they want us to find average velocity in miles per hour. Now, probably what we should do here is go ahead and take our given values and go ahead and convert them to miles and hours. It'd probably be a lot easier. You could go ahead and solve for the answer in meters per minute and then convert that to miles per hour, but it really doesn't make a difference how you do it. Either way is acceptable. So if I was going to convert 1,200 meters to miles, I'd need to go miles to kilometers. Meters to kilometers. So in 1 meter, there's 1,000, or 1 kilometer is 1,000 meters. And then there's 1.61 kilometers in 1 mile. So we would do 1,200 divided by 1,000 divided by 1.61, and that gives us with about 0.745 miles. And then if we were going to take our time in minutes and convert it to hours, we would simply take our minute to hour conversion. 1 hour is 60 minutes. So 1.2 divided by 60 gives us 0.02 hours. All right. Well, what if he covers 0.745 miles in 0.02 hours? Well, average velocity we know is delta x divided by change in time. So our delta x is 0.745. Let's get rid of that. 0.745 miles divided by 0.02 hours. 0.02 hours. And 0.745 miles divided by 0.02 hours is 37 miles per hour. And we don't have a direction here, but it does ask for velocity, so I'm just going to give it a direction south. You could put a positive sign if you wanted to. I really don't know much about the direction, but since they're asking for velocity, we should have a direction in our answer. So 37 miles per hour there. Now, hopefully, on all these problems, you are pausing and working a problem out before I'm doing it, because it really doesn't help much if you're just watching me do a problem. One thing I don't want to forget to do is go through the skier average velocity. In our slide for average velocity, we found that the skier displacement was 140 meters to the right. We can just put a positive on there. And the total minutes for the skier on that was 3 minutes. So if you wanted to find the average velocity for the skier, it would be 47 meters per minute. And you would keep that plus sign on there to indicate it was to the right. Or you can just put the word right. But you wouldn't put both this and this. That wouldn't make any sense. So that would be the answer for the average velocity for the skier. Earlier we said the average speed was 140 meters per minute, so definitely not the same thing. And then for the coach, his average velocity would be the negative 55 yards would be the displacement. Remember, we got that by subtracting the negative 5 minus 50 to get negative 55. And then how long was he pacing? 10 minutes. So that would end up giving us 5.5 yards per minute. And we would have a negative sign. That would indicate he was pacing to the left. So that's how you would end up calculating the average velocity for those two problems. Last problem. On a road trip from San Diego to California to Seattle, Washington, your friend drives 350 miles north. So I'm going to call that X1, 350 miles north at 55 miles per hour. So I'm going to call that V1 because that's the first velocity given. And since it's a velocity, it needs a direction, so I'm going to give it north. You stop at McDonald's for 0.5 hours. Well, what would your velocity be there? Well, it wouldn't be anything because you're not moving, right? There's no displacement. So 0 miles per hour. And how much time we stopped there? Okay, we can get that. T2 is 0.5 hours. Notice how I'm keeping the subscripts the same for each little section of the trip. Then you take the wheel and finish the last 850 miles. Okay, so X3 is 850 miles. And we know it's north because we're still traveling to Seattle. At 63 miles per hour. So V3 is 63 miles per hour north. The question says for us to see how long does it take, so we're finding total time. And what's your average velocity? So that's going to be our total displacement. Well, we would break this down into 3 parts. We know how far we traveled at the first stage, but we don't know how long that took. So why don't we figure out what T2 would be? And that would help us later on, because total time would be T1 plus T2 plus T3. So let's find the time for the first segment. So V1 equals X1, or you could put triangle X if you want, over T1. I'm trying to find T1. If I rearrange, T1 would be X1 divided by V1. Well, what was X1? X1 was 350 miles divided by V1, which was 55 miles per hour. Miles cancel. 350 divided by 55 ends up giving us 6.36 hours. 6.36 hours. So there's T1. Do we know how long T2 was? Yeah, we already know that because that was when we were just eating at McDonald's and we spent half an hour there. Do we know how long the third segment of the trip was? No, we don't know that. But isn't it the same setup? If we wanted to find the time for the third segment, wouldn't we just rearrange that formula right there and solve for T3? Sure enough, let's do that. So T3 equals X3 divided by V3. What was X3? X3 was 850 miles. And V3 was 63. So when we divide our 850 divided by our 63 miles per hour, we end up with T3 being 13.49 hours. All right, do we have enough for this? Well, let's see. We have T3, we have T1, and we have T2. So all I would have to do here is add them all up. So it would be 0.5. Well, let's do it in the order that's listed. 6.36 plus 0.5 plus 13.49 and that ends up giving us 20.35 hours for our first answer. So 20.35 hours to make the driving trip. And then the last part of the question says, what was your average velocity? Well, I run out of space here. So let's erase a little bit of what we've already done. Let's get rid of some of our values we don't need anymore. We don't need that. We don't need that. That might give us enough space right there. What would we need if we wanted to find average velocity? Well, average velocity is total distance, or excuse me, total displacement divided by total time. Well, I know the total time now. I just calculated that. But I don't know the total distance, do I? But can I find the total distance? Do I know how far I went in the first segment? 350. Do I know how far I went in the third segment? 850. How far did I go with in the middle segment? Well, I didn't go anywhere. I was eating hamburgers. So we know that that's distance doesn't really count because you didn't go any distance. So we're going to do 850 plus 350. You know what? Let's go back to red so you guys can see the difference. Or whatever it is. Pink. 350 plus 850 over the total time, which is way over here, right? 20.35 hours. And when we when we add up 350 plus 850 and we divide that by 20.35, we get 59 miles per hour. So there's our second answer, 59 miles per hour. That was your average velocity for the whole trip. But we're missing something, aren't we? Because a velocity has to have direction. So I'm going to put a big N on the end there, and that will take care of, so 59 miles per hour north would be our answer. You could indicate the north with a positive sign if you like. But you wouldn't put it twice. It wouldn't make any sense to put a plus and then put in as well. All right. Let's go back